All right, up until this point, we have been talking about logarithms. We have been talking about exponentials, okay? We've been talking about how we can take the inverse of a log, the inverse of an exponential, all right? Well, in this video, we're going to be talking about something called natural log, all right, in base E, all right? So for example, if you had a log written like this, y equals log x, well, we know that this naturally has a base of 10. So for example, this really has a base of 10, but we don't write it, okay? We just know it's there. Well, if I erase this, what if you have this? Y equals log base e to the x. Now we're going to get into what e is in a little bit, but if you have log base e to the x, okay, well, we can rewrite this as something called a natural log. So this can be rewritten as, in which natural log is called ln, so ln x, okay? And this ln of x has a base of e. Just like log x has a base of 10, ln x has a base of e. So for example, even though it's not written here, this ln will have a base of e, okay? Even though we don't write it, it's there. Now, if I wanted to take the inverse of this natural log, okay, we're going to follow the same steps as we would, okay, when finding the inverse of any type of log, right? It behaves just like a log, but now it's called natural log because it has a base of e. All right, so for example, if I wanted to find the inverse of natural log, well, the first thing I need to do is put it into its exponential form. So using our log equations up here, we know that y equals log base e of x is the same thing as ln of x. Right? So if I wanted to find the inverse of natural log x, okay, what I would do here is put this into its exponential form. So I'm going to go ahead and do that, and using the equations here, we can do that. So in its exponential form, it's x equals e to the y. And then to take the inverse, we simply just switch out the y and the x. So the inverse here would be y equals e to the x, okay? So again, the inverse of this natural log will be an exponential, and the exponential has a base of e, all right? Okay, let's get into real quickly what e is. Okay, let's get into what e is. So e comes from compound interest. Now I know that this isn't a finance class or an investing class, okay? But it's good to know where it comes from. So the formula for compound interest is, I'll write it up here, A equals P, and then we have in parentheses 1 plus R all over N, and then we have N T. Let's go ahead and define some of these values, right? A is going to be your total amount, okay, after we go through this formula. P is your amount that you invest, okay? So P, you can say, is the principal, so the amount that you invest. So let's put that in there, principal. R is your rate. So for example, that would be 8%. N is the amount of times it's compounded, right? And T is your time. Well, E, okay, comes from compound interest. And a man named by Euler wanted to know what would happen if he invested a dollar, okay, at a rate of 100%, okay, for 1 year, okay, and compounded it n times. So for example, that new formula would look like this. If you invested a dollar, it's just going to be 1, so we don't have to write 1 here, okay? And it's going to be 1 plus 100%, so 1.00. Right, convert it into a decimal. And then n times, and then for 1 year, right? So we can just write n here, n times 1, right? So just n. Well, he wanted to know what would happen as n keeps getting greater and greater and greater and greater. And what he found was there comes a point where it doesn't matter how big n gets, okay, or how many times you compound it. Eventually, this is going to reach a set point where it can't get any bigger. And we call that e. So if you were to go ahead and put this into your calculator here, you would find that when you plug in a number for n, once you reach a certain point, no matter how big that number is, okay, your number can only get so big, and that's called e. All right, so we call that e, or Euler's number, and it's about, okay, we say here 2.7182, right, and it keeps going on. So you can't get past this amount, all right? That's what Euler found, and again, this is called Euler's number, or E. Okay, so that is where E came from. It's used in finance, okay, in investing. All right, and that's pretty much all we need to know at this point, but just a little background, that is where E comes from. Now, let's get into some real problems here dealing with base E and natural log.